We should start.
Yes, we should start. Right. I think we still are missing quite a lot of people. I have got some indications that the train connections to Stockholm is a bit late. We'll see if that is the cause or not. Nevertheless, we prioritize you in the room and our friends on YouTube, which I guess are with us. If so, yes, we welcome them. They have probably heard our chatter already. What's this about linked data? So yes, first one more thing. I will not make a full welcome introduction right now because that we will have around 10 o'clock when more people arrive. So this tutorial is, well, not everyone can be here as early, and not everyone is perhaps interested in a tutorial on linked data because maybe they feel like it's in their back pocket already. So we will therefore postpone that introduction to 10 o'clock after the break with coffee and some sandwiches, I think. So, right, so without further ado, linked data. Why am I to talk about this? Just very briefly about my background. I have actually done a thesis on how to build modern web application using semantic web linked data. So it's not many times that you got a chance to actually, sell your thesis, but here's one of those times. So I have quite a lot of experience with both academically and also practically with working with linked data. I've been starting with it already around 2001, even though it wasn't called linked data at the time. So I'm CTO of Meta Solutions, a company that specializes in linked data technologies here in Sweden. I also do a lot of development, and a few of my babies are Interscape and RDF forms. So first, now I'm going to have a few of these slides which just says basically, if you want to see more, go here. And also I should mention that, let's see now if I have my slides have links, and then you can investigate for yourself. So, so linked data and the web architecture, how does it fit into how the web is organized? I'm not going to...
Can I inform a practical matter? We are not allowed to bring any coffee or any drinks into this room with this way of organizing the chairs, unfortunately. There is some technology under the floor that will cut out the electricity if there comes any. So I'm sorry about that. I'm a coffee drinker.
Maybe we should put up a note or something.
Yeah, I guess. I should have informed about it earlier. I'm sorry to take it this late.
Oh, I know. Let's put up a note.
Roger coffee again after this session.
New coffee after this session. So sorry about that interruption, folks, online. It's a health hazard to drink coffee in this room. So we are moving things. Some people are moving their coffee out of the room. So linked data and web architecture. I did this picture when I was trying to get a grasp of how everything connects, and you see it's quite a complex picture, which I'm not going to explain. I'm just going to show you that linked data is the yellow part here in the middle, and there are things missing here, which is something I was actually going in deep in my thesis. So if you want to read up about this, you should check out my chapter number 3 in the thesis. Is about architectures, technologies, and application types. And the first part of the chapter is very much relevant for this. So what's linked data? Linked data was originally proposed by Sir Tim Berners-Lee, the founder of the web, already in the beginning of the 2000s, somewhere 2001 or something. Well, not linked data, but the principles behind it, and then it has grown, or actually the principles were a bit later, but the founding, what's called semantic web, and a lot of these things were already proposed early, maybe 99 and so on. And then the principles of linked data was 2006 or something. He has this crazy talk where he describes the concepts behind linked data, where he basically says that, okay, you have a person, he lives in Berlin, Berlin is in Germany, and there's relationships, and the relationships are given by the HTTP URLs, so you can go and look those things up. You can find the city where you was born, which region is it in, and the population, which population, and so on. So everything is linked, and this is what you know already. This is the web. That's how it works. You just follow links, right? But unfortunately, that's not the case with data. Actually, what is the state of data? Data is basically take the web, remove the links, remove the common format. That's kind of problematic. Every time you consume some data, you have to learn about the data format. You have to learn about the concept, the way they think about their data. You have to somehow maybe do some development to actually be able to consume that data. And yeah, maybe you need to do the same thing with another source to integrate it. So linked data is this crazy vision that let's make it as easy as the web, but with data. So there is a nice presentation at TED Talk from Sir Tim Berners-Lee, where you can see this. So basically, what is linked data again? I'm going to come back to this a couple of times. It's statements about things. So what is a thing? Thing can be many things. It's persons, places, drugs, historical events, pictures, text documents, etc. Anything you can think of that is kind of having an identity and it's possible to talk about it, then it's something that you can express statements around as linked data. So principles here, important principles is that you should make the things addressable, typically by providing URIs or web addresses using the HTTP protocol. And then you should use a common model for expressing your statements. That's RDF. We're going to come back to that. And also you want to link things together and express relations between things. So given that, why do we do linked data? I think you already got part of it, but let's go in some detail. It is easy to understand and reuse other people's data if they have committed themselves to something you already know. If they're expressing their data in a way you already, using vocabulary standards, concept schemes, whatever you want to call them, if they're expressing themselves using things that you already know, the words you know, it's easier for you to consume their data. And you can also reuse their data. You can yes, so you can also make your data better by making it accessible on the web. So of course you can get the data from someone else on a USB stick, but it's even better if you get it in the form of a URL. You can go there, you can consume it whenever you want. You can cache it locally. It follows the formats that you're accustomed with. So it also helps search engines to index your information better. You see in the knowledge panels when you're searching something on Google, you don't only get the search results nowadays, you also get this kind of info boxes or knowledge panels, they call them, on the side, which is driven basically by linked data, given by graph-based expressions that they call the knowledge graph, but basically that's linked data. Follows the same principles. So then, if you have your data and you start expressing it using this common format in RDF, you can actually point to other pieces of data that is already out there. You don't have to duplicate that information in your information model to make your data complete. You can just say, hey, this is what I'm good at, here's my data, and if you want to know something more about this part, just follow the link and go there. So that means that you can focus on your data and make added value by making that one really good. So you do linking. So finally, or not finally, but one of the things I want to highlight here, it allows you to use established techniques for machine processing. Some called inference, sometimes called reasoning. It means basically someone expressed something in general terms, you can make it more specific. You can draw conclusions from the data that is maybe not explicitly expressed. So the 4 points again: share data model, find and access data easily, connect the data using links, and reason about data. So now I'm going to go into these 4 points with more like examples and say how RDF or linked data actually solves this. There are many data models. Here you see 2 data models, somehow related to persons. Here is something called the IMS, Person Management Service. It's learning technologies standards. And it describes a person with the format, name, recording, email, URL, etc. And there are some related objects here that it connects to. Here is another one, which is an early version of the European Commission's ISA, the core vocabulary, and their view of a person and is how it connects to it. Very important that it has identifiers and locations, and over here is addresses. Well, the model is a bit different, so to transform between these models is non-trivial, especially since they may not use the same format. This one actually uses RDF, this one uses XML. The information models differ. One is more hierarchical, one is more graph-based. So linked data tries to provide a solution for this by providing a basis for defining, extending, and reusing data models. So if you need to have a data model, use it, express it using linked data principles, and you will be up and running rather quickly. That's the idea. And you can reuse other models. So how do I find and access data? Well, now, think without linked data, you have to know which system is it in. How do I find the data? Do I have to make a web service request to get out the data? Maybe you get an XML SOAP message back. That's how you retrieve the data. And then you have to understand the format. And even if you have a syntactical description of how the data actually looks like, you still have to understand the data. Is a person really a person the way you understand it? Maybe they are talking about something else. Well, maybe if they called it person, it's probably a person. But there are many other objects that are not so clearly defined just by the simple name. So the semantics, the meaning of the data is still sometimes unclear. So here is one of the established old standards. This is for describing a contact using the vCard expression. There is an RFC for that, and you can retrieve it over HTTP. There is MIME type. So the solution with linked data is that let's use URIs always. No web services. Don't hide information in complicated protocols. Use HTTP. HTTP is very commonly used now for over the web. So let's use it. There is even a common query language to querying the data structures, and we will go into that in detail, or some detail. And there are many standardized formats. So then, connect data, point number 3. So if you have so this is the linking things. You have a user living in a building, and just living in is one of many different relations that you can have. So how do you get to the building information? Well, it may be in another system, it may be maintained by another organization, it may be expressed in another information model. So again, I'm hammering in the message here. Linked data is a graph, it has links between things, and it relies on an ever-set growing of vocabularies to capture different sets of data, which means that you may recognize what they are saying even though you don't know exactly their information model. You may know some parts of it, which is already a good thing. Then, reason about data. So, just think of all the integers. You can't express all integers. That's infinite amount. So, you can't express all data. Mathematical truth is one thing. But even ignoring that, you still have a lot of data that is somehow hidden. You can't draw all conclusions because it would just explode up. You will need to use a lot of data storage. So that's why we have rules to be able to draw conclusions from the data, and some of this information can be answered after a query being posted. Right. So linked data comes with a couple of extensions or layers, allowing you to define classes and properties and rules allowing you to make inference and do reasoning. So this is part of the package of linked data. You can do reasoning. So now I've done some motivation here, why we should use linked data. I'm now going to go into how linked data works in practice. Not all part of it, because there are many aspects of linked data, but the important ones. And I'm going to come back to this list, and I'm going to cross over them when we've done them. So, identifying things. And now we are getting help here from Hans from Nobel Media, and we are going to take his example of Nobel Prizes because they are widely known. You don't need an explanation for that information model. So here we have a picture of Marie Curie. So how do we identify her? So she is not a digital object, and she is actually a person that is dead. So, and she doesn't have a social security number or state-issued number. So what do? Well, we give her a URI, an identifier. Here's a web address. datanobelprize.org, resource laureate 6. And the laureate thing indicates that, she may be a Nobel laureate, and yes. But just as an aside, why do we need to use HTTP? Just want to, for further reference, if you go back to the slides at some point in the future, there are a lot of good reasons for using HTTP URLs. And there's in web architecture, in the cool URLs of semantic web, Tim Berners-Lee's design issues, and best practices for publishing linked data. All of them says use HTTP. And maybe I'm kicking in open doors with that one, but just so you know, there's a lot of good heavyweight people pushing in this direction. So having full web addresses can be a bit cumbersome. So let's abbreviate. Let's bring down some kind of, and I realize now that these choice of these namespaces are a bit easy to confuse, but it's NPL for laureate, NPT for terms, and a Nobel Prize prize, NPP, for the actual prizes. So now the identifier for Marie Curie can now be shortened to NPL6. And we want to make two statements. The first statement is that we want to give her full name. It's Marie Curie, and then I can't pronounce the rest. At least not the ni thing. And then she got the Nobel Prize. And that's NPP Physics 1903. So, let's be practical. We want to state two things. First, we want to state that, remember the identifier for Marie Curie has a name, actually, right. In the rest of the thing, I've changed it to RDFS label. I see there's a discrepancy here. But actually, in the graph, both are expressed. But you can think of, it should be RDFS label here. So the relation is label or name to an object. And Marie Curie also has a Nobel Prize. This is the Nobel Prize. The relation says Nobel Prize. We're connecting two things, Marie Curie and the Nobel Prize, which means that we are considering the Nobel Prize to be a thing, an entity, which we can describe and make statements around. So this is kind of a tabular way of looking at it. And here is a graph way of looking at it. So the difference is basically that we see that both these statements have the same subject. They start from the same entity, the same graph node. And here we say RDF's label and Nobel Prize. Now we make it linked data. And actually it's not a big step. We're basically saying that let's put this graph on the URLs we are using as identifiers, which means that if we go to them, we'll actually get the linked data. So if I click here on Marie Curie, I will open a tab and I will get information about Marie Curie. And you see there are much more statements here than there is in the other one. I will go back again. And now I'm going to do the same thing, but in the slide. So now I click on the physics one. That means I'm following a link to the Nobel Prize. And now we get a different graph. One with 1, 2, 3, 4, 5, 6 statements, One saying that the type of this one is an award, a DBpedia award. The label is Physics 1903, and it's actually, the label is in English. It has actually 3 laureates. One is, you recognize this one as Marie Curie, but then we have one that is NPL 5 and NPL 4. And to actually know what they are, you can probably guess the other one if you know your history, Pierre Curie. But this one you may not know. That they got it actually together, there were 3 of them, they got the Nobel Prize. And the third one, can I click, is Antoine Henri Becquerel, which you may know as well. Also, we can express data types using, just data types as part of the string. One more thing here to notice is that we can click on the nodes, but we can also click on the edges, the labeled edges we have in RDF, the predicates that connects the things. They are also full URLs, which means that if you don't understand the relation between 2 things, you just basically look it up. You put it into your web browser and you typically will get an explanation of what it is. So together, now this is kind of an abstract view. This is not the Marie Curie case anymore. It's just that here you have a node, which is the subject. Then you have a predicate, and then you have an object. And the object can be a string, either a plain with language, tag, or data type. Or it can be an object in the form of a URI, or it can be something called blank nodes, which is basically data structures inside of the graph, where you need to group things together. Then you use blank nodes. They are not addressable from the outside, but they are very useful sometimes when you need to have data structures. So a statement is sometimes referred to as a triple, so you will see those used synonymously. And several statements forms an RDF graph. And the RDF graphs are located at specific URIs where you can load them. Now we have already covered 4 of the things that we want to know how linked data works. We have understood that we can identify things, we can make statements about things. We have seen that there is a language for making these statements, that's the RDF. I haven't really written it out, Resource Description Framework. Resource is another word for thing, basically. It's the web architecture word for thing. Yes, and we can look things up on the web. We haven't talked about how to actually, well, okay, now we know how to build a data model with an information model. How do we store the information? And then how do we exchange this? Well, we've seen a little bit, we've seen something that looked like a table, we've seen something that looked like a graph, but we need to have a syntax, some way to transfer the information. So that's how to exchange the statements. And then we will look at how querying the statements works. To store linked data, I would say that there are basically 3 alternatives. First alternative is to have something called a triple store. A triple store is a specialized piece of software that is very good at keeping tabs of a graph. So it's like there are graph databases. Graph databases are, this is a special breed of a graph database. Good, very good just for linked data. And it allows 2 things. One is to access the actual triples in RDF format. And the other one is to use Sparkle to send queries. Both of them are, the Sparkle I will get back to. The second alternative is to say, no, I don't want to throw out my system. I have already a traditional database and I'm very happy with it. Then you can make a synchronized, maybe nightly synchronized operation to a triple store. So you have to, in the sync operation here, define how your information model expressed in a relational database maps to a graph representation in the triple store. And then you get all the added value here again. You can access this as RDF, you can query it. And then you have the third option, which is that, well, let's make this quick and hacky. I have a traditional database. I need to produce something that looks like RDF. I make a template or some, I don't know, JSP or FreeMarker, whatever template-based language, or you write your own code to export this as XML or one of the formats that is available for RDF. Then you typically you don't have the energy to do that in so many formats, so you don't get the benefit of having a triple store, which is really good at this, and you can't query it because the information is not here, it's just here on demand. So someone asks, can you give me information about Marie Curie? And then it goes over here to fetch it, and you get it out. Actually, the way we've done it with Nobel Media and then Marie Curie and all the Nobel Prizes, it's alternative 2. So, not recommended, as you understand. But it is the quickest way, so it's better than nothing, so that's why I mention it. So then I want, since I'm working with EntryStore daily or nearly daily, I wanted to say that a triple store in itself doesn't need to be everything. There can be more things on top of it. So there are other products as well, but in this case we have a triple store together with the Solr index, which allows you to do free text searches and files that allow you to store, like resources that are digital files. You can store them together with the metadata, the information expressed in RDF. And then we have more, like we have the REST API for Solr, and then we have Sparkle and link data. And then we can also have some harvesting, like OAI, PMH, other attack vectors to change the information. And then you can build web applications on top of it. Just want to mention that a triple store in itself doesn't need to be everything. You can, in many cases, you need to build more things on top of it. And there are ready-made solutions, and then you can build yourself. So, now that was the storage part. What about actually exchanging the information? How do you do it? I mean, you can't send this nicely diagram in a PNG, it's an image. You need to have a syntax. And there are a few. First, let's start with the recommended ones. Turtle, it's a quite nice format, recommended in 2014. You do these things like defining prefixes, like the namespaces we did a couple of slides back. And then you have here the actual expression. It says like NPL 6, that's Marie Curie, if you remember. Label, Marie Curie, Slowodska. And then semicolon means that I'm not done yet. I want to say something more about Marie Curie. So here it's one, Nobel Prize in Physics, 1903. Dot, full stop. That's it. So it's kind of a compact format. It can be, I mean, I don't need to make it such compact. I can make it much more verbose by actually not using the prefixes and having full URLs everywhere, but that would make it much harder to read. So, easy to read and write, often used in examples, in standards and specifications. There is a MIME type as well. Did I jump over one? Yes. So, next one. JSON LD. This one is also 2014, and this one is compatible with plain JSON, so it's very developer friendly. So if you have some API already, you can actually slap on something called a context, which interprets the expression as linked data. This is very handy. The developers doesn't need to actually learn linked data. They can actually be given, they can just include this. And actually the context, you don't even have to have it inline in the JSON structure. It can be a context, a reference to a definition elsewhere, which just enhances your JSON structure. And here, the context says, whenever you stumble upon an attribute label, you should expand that into the full URL RDF schema label. And this first is the ID, which is the subject of the statement, right? So here it's, the subject, predicate, object, predicate, object. I didn't shorten that one. That's possible as well to provide shortcuts, but okay, third format. So you want to embed RDF inside of HTML. Yes, that's what you can do with RDFA. So that means that, okay, I have my web page. I have a title, I have a paragraph with some information. Maybe that's a description or full, something about Marie Curie. So here, it's a bit hard to read HTML sometimes. So here's the body, and it just first defines a couple of prefixes. You recognize prefix? We had them in Turtle as well. Here it says that NPT stands for this, RDFS stands for this. Then resource basically means that, okay, I'm talking about laureate number 6. That's Marie Curie. And then I have a heading, which is Marie Curie Sklodowska. And then I'm saying inside of the as an attribute that the property is RDF's label. So interpret this. This actually constructs a statement for us with the subject being the resource, the predicate being here. Predicate and property are two synonymous ways of talking about the middle part in the triple. Label, and the object is inside of the tags. Here we have another one. Marie received the Nobel Prize in, you see it's very nicely written like just regular text because it's HTML. It's going to be a web page. Marie received the Nobel Prize in, and then we have a link. Nobel Prize in Physics 1903, and then the nice label for it as well. So to get this to work, we just have to specify the link target, which is the object in the statement, and the predicate, which is a Nobel Prize. So V3C recommendation in 2015, and it's very useful for embedding RDF, and it's good for search engines. Checking the time. Okay. And you see the MIME type is simple in this case, text HTML. Now we have the bad boy. RDF XML. So this was the first recommendation, a standardization for expressing RDF, the official recommended version. It has a lot of problems. People think that this is XML, but it's not. Actually, there are so many different ways of expressing a graph and as an XML structure that people, when they're trying to write it, they are mixing up the XML syntax with the actual RDF structure, so they're just doing weird things. There's something called the striped syntax, allowing you to every other time do a resource predicate inside of it, making it very deep structures, which is also very confusing for people that, well, it's very natural for people doing an XML because they are accustomed to tree structures in XML, but the interpretation can be very easily done totally wrong. So it's overly complicated, has a lot of people that says that don't use this. So avoid it if you can, and never write it by hand or just treat it as pure XML. There were actually the first, one of the early standards for news flows, RSS, was done like this, and it was not good. It was done in something that could be interpreted as XML, could be interpreted as RDF. And if you want to read all the witnesses or people saying don't, this has been very negative for the RDF community or the linked data community. Okay. Sparkle, what's this about? So we can do the two ways. We can ask you, what does this one do? Enhanced context, he knows already. I guess, you don't know the syntax, so, hard for you, but let's read it together. It says that I want to find a laureate who is a laureate. Or I want to find a thing that is a laureate in a variable called laureate. I want to have the label in a variable called name. I want the gender to be female. I want there to be a birthplace, Sweden. And then there is a connection to something called the laureate award. And the award, now we are talking about the award, not the laureate, should have a label. And then I'm saying also that please give me a motivation from the award and filter the award to motivation so I get it only in English. So I'm looking for female Swedish Nobel laureates, and I want to get the motivation. So let's run it. I'm getting, it doesn't really like me clicking on the, now. Here's the query again. And now at the bottom we see that we found two results. One is Alva Myrdal, it's a Peace Prize, and the other one is Selma Lagerlöf. And we got the motivation only for one of them. I don't know why. There's a missing motivation here. Maybe Hans can explain.
The Peace Prize doesn't have motivations.
Okay. Because it's given by the Norwegians, I guess. I would have liked to have one for Obama. It's a bit early. Anyway, we close and we do present again. Right, so want to do another one? Oh yes. Okay, so this one, I barely remember this one. Let's see now. Again, a laureate, and we want to have the name. Actually, the name is both FOF name and RDFS label. It's duplicated, so maybe if there is, you recognize that, oh, that was wrong. It's both. I want to have the birthplace, Sweden, again. I want to have the laureate award, yes. And I want to get something called share from the Nobel Award. And the filter is that share should be bigger than 1. So share, the shared Nobel Prize, Nobel Prizes can be shared by up to 3 persons. And you're saying, here the query says that I want to see only those Nobel Prizes that are shared with more than 1 person. Okay, so you can't share it with yourself, but which ones are the Swedish Nobel laureates that share the Nobel Prizes? Let's run the query. Now it's above the thing, so I should get it out here. And then we will see that, yes, we got some Swedish Nobel laureates. We'll find Alva Myrdal there, for instance. So she shared it with some person from Mexico, I think. Right? Yeah. Let's see who she shared it with. Let's see. Alva Myrdal. I'm going to copy this URL because I don't trust the link they have there. Okay, now we have Alva Myrdal. So I want to go from Alva Myrdal to the Nobel Peace Prize here. I want to see the laureates. We have 543. It's okay, marked as I visited, so I guess I should go to this one. Okay, Alfonso Garcia Robles. So, who is that? Maybe I could go and see more information because not everything is in the Nobel Media's database. So, let's see if there is more information at DBpedia. So, DBpedia is the linked data version of Wikipedia, which is now being deprecated or slowly being phased out in favor of something called Wikidata. That's a whole another talk, but we can click on this one, and yes, we got to some information about the Mexican diplomat and politician who got the Peace Prize together with Alva Myrdal. So here I can see a lot more information. And if I'm wondering what is something else, then I can just follow it. So this is what Tim Berners-Lee talks about. I just click away. I get to more information. And this is nice for the human being, but it's also very nice for the machine when you build a system that can consume data. All right. Consuming my time? Yes. Now, we've done the querying. We got the storage of data. We got how to exchange it using various formats. Let's look at how to actually extend your vocabulary. Because now you've seen that there are a few ways to express statements like RDF's label and Nobel Media's relations between Nobel Prize laureates, etc. So how do you define more vocabulary? So I'm going to say a little bit about how to build vocabularies using vocabularies. Yay. And then look at a few well-known vocabularies. So also the term vocabulary, sometimes called ontology, sometimes called schema. So, beloved child, many names. So let's start with SKOS, the Simple Knowledge Organization System. Now I didn't have the energy to draw my own picture, so I took one from an early version of the standard, or the primer. Here we are defining a concept with a name, economic cooperation. Now, economic cooperation has more refined concepts that we may need to use sometimes. So there is a narrower concept, which is economic integration. There is another one which is European economic cooperation, and there is a third, or fourth perhaps, the four of them, European industrial cooperation and industrial cooperation. All of them are narrower. So you can form relations, hierarchical relations, via narrow and broader relations. You can also have labels. Now you've seen already, I read them out loud, a few labels that are preferred labels, but you can also have alternative labels. This diagram focuses on one of the concepts, so you don't see all the statements of the or the narrower concepts. So that's why you're missing the alt labels and stuff on those here. So then we can have also notes. So explaining like the scope of this concept, that here what's the purpose of this? You can have a definition as well. You can have a historical note, editorial note. There are a few different notes you can use. So SKOS is about defining these relations and the type being a concept. And a few other things. There is also a way of relating between concept schemes, they call them. So, but we're not going to go in all this. This is not about defining RDF's label, defining FOF name, or all of these things that exist that I mentioned a little bit earlier. This is defining concept schemes, hierarchies of concepts. Now, if you need to define new classes and properties, like in the case of Marie Curie was a laureate, and she had a relation to the Nobel Prize. The relation between those was a statement with a predicate, and the predicate or a property is the laureate relation. So that one is a type of a property. So you're seeing here we're actually using RDF to define new terms in RDF, or new classes and properties. So it takes a little bit to get used to this, but it's very powerful. So we're defining laureate, the class, Nobel Prize. Both of them are classes. This one actually is a subclass of another class, fourth person, that's defined elsewhere, which is also a class with a big C, and some labels. So there is a lot more to know about this. I'm just scratching the surface. Then there is one more very powerful way of defining classes and properties. It gives you the possibility of doing restrictions, like you're only allowed to have 1 year for a Nobel Prize. It can't be issued twice, right? Wouldn't make sense. So if you want to actually enforce that in a system, you can use an ontology and restrict the year relation to be only once. You can have 2 labels perhaps, one in English and one in Swedish, but you can't have 2 years. For that, you need to go to OWL to do cardinality restrictions. There's a way of doing an equivalence, saying that, someone defined the fourth person here, and Then we have the ESA person over here. They are actually the same class defined by two organizations, but we are going to treat them the same. There is transitivity, reflexivity, inverse relations, a lot of things that you can say about relations, like has part of is the inverse of part of. No, has part is inverse of has part of. Well, okay. Easy to get it wrong. Okay, you can do enumerations, you can do property chains like has parent, has parent, has parent will define has ancestor as like if you have one or many relations between two things. Now we're going into something more concrete. Now we left the vocabularies for defining vocabularies, and now we're going into one specific vocabulary, more specifically the most known one, which is Dublin Core. Dublin Core was introduced already in '95 by library communities, the library community, a lot of organizations in Dublin, Ohio. Here's the specification. It was originally 15 of them, very useful to defining typically books or articles or online resources to say when was it published, what's the title, who's the author, all these things. So now it's around, I don't know how many that is. Probably not all of them. So I think it's around 60 predicates, properties that you can use in various situations. They are very widely defined, which means that they're very easy to appropriate into a new setting. That's made this vocabulary very successful. FOF is another one, focusing on how to describe people and organizations, friend of a friend. So you have like an agent, which is the superclass, and you have person and group organization, you have online accounts, you have documents, a lot of things. Here you see a lot of the properties. By mistake, I had FOF name here somewhere. Gone. Anyway, they have some deprecated properties that shouldn't be used anymore, like first name, last name. Instead, you should use given name and family name, which they learned over time when this vocabulary became more used widely internationally, and they realized that first name, last name isn't as good as they thought from a Western perspective when it was used in China, for instance. So given name and family name apparently was a better way of characterizing names. So sometimes these vocabularies grow over time. That can be problematic if they have a large user base, because then you have to think of backwards compatibility. Then we have schema.org. So the big search giants, Bing, Google, Yandex, Yahoo, they introduced something called schema.org in 2011. It's been going up and down a bit. It was over 800 types for some time. And a lot of properties. And this is an old picture, so it's probably not correct anymore. But this purpose is to improve search. And we already mentioned the knowledge panels on the side of your searches. Those are driven by information that, to some extent, are extracted from web pages which have expressed information using this vocabulary. So there is now, why the number has gone down is not because it's like it is very successful. So successful that a lot of more classes has been defined and they needed to handle that. That meant that they moved them out into extensions for the auto industry, bibliography, health, and Internet of Things. So I just, again, scratched the surface here. There are so many vocabularies out there. Few of them are very well known. Few of them are less known. To find them all, well, then there is a special place where you can search for vocabularies. That's linked open vocabularies. So this is they have this on the first web page where I think it's rendered more or less in over the time when new vocabularies arrive. So you can see that there's divided vocabularies into different sectors here, like the city sector, the library community. It's really hard to read here. I can't even read it here, stand like 40 centimeters here. So you have to go to the web page and see. Oh, done with how linked data works. So to summarize, data will become part of the web if you use linked data. I think that's an important message. Also, it gives you improved search. If you are using, for instance, schema.org and vocabularies that are well known, the search engines will better understand you and better index your web page. Maybe you will even show up in a knowledge panel. Interoperability, having multiple data models. How do you actually go forward? Well, let's do it the web way. Let's let 1,000 flowers bloom, and then the best one will survive, and there will be a consensus, hopefully. Well, sometimes there won't be a consensus, but that probably means that you have different use cases. And then there is a reason for why these models actually need to exist and coexist. So interoperability is about having information being interpreted correctly in another system by reusing established vocabularies. That's the way linked data works. Interoperability and reusable data models are quite kind of close. Powerful expressions. Since we're using a graph-based way of representing information, it's very powerful. There's not like a restriction that, oh no, you can't express dates in RDF. You can. There's a data type for that. You can do anything with linked data. Can you do everything nicely with linked data? Are there restrictions? Yes. There are things that are probably not as good to do in linked data as in other formats. I would say, for instance, the weather data from SMH, the Swedish National Health? No, not health. Sorry? Meteorological Institute. There is so huge amounts of data that you get every day that you really need to think of how to do that in a compact way. So you probably need to do it in formats that are very dedicated to that. That doesn't mean that it's not possible to interpret this as linked data. And we will have another talk today of a large-scale linked data. Samuel will say something about this. I think it connects. So I'm just saying that not always natively linked data in these verbose formats, but you can interpret it as linked data. And we get increased quality by using links. A couple of years back, we did something called a vitbok, or a white paper, if it's translated correctly, I don't know. Which is an attempt to do a nice introduction to linked data in the Swedish language. It's still there. I think it's still relevant. So here's a direct link. Some of the things I brought up, the reason why to do linked data is more or less translations from that web page. It's supposed to be a live linked data resource in Swedish. So if any one of you feels like that there is something wrong or you would like us to improve it, it's just to do a pull request on GitHub to improve it. I think that was more or less it. 1 minute before. So I leave you with that. And if someone is really interested, I have a couple of copies of my thesis of how linked data connects to the web. Right. I'm not sure if I should take questions now, or maybe we should just say like, thank you for listening, and now we will take a break and let a few others that are coming late join us, and we will take some snacks or sandwiches and coffee.
There is something.
We have 30 minutes for fika, and people can approach you if they have questions.
Yes. Yes.
We haven't came with the new, but they will come.
They will come.
Yeah.
And for, are they still with us?
Yes.
The viewers online, we have divided the the sessions into 4 different streams. So you can find them online if you haven't found them already. Just switch stream to see the next set of presentations, the next session. Okay.
You should mention the URL. Länkade data.
lankadedata.se.LDSV/2018.
Yes. So I hope they will come with a new fika just in a minute. Just wanted to inform that the toilets are, if you go out through the glass door and then to the right across the hallway somewhere there.